This is a breaking news. We interrupt this broadcast to bring you the latest news about the Lawsin Conjecture, coming to you live from the author's laboratory facilities. Our very own news broadcaster is on the scene now. Let's go to him, Liv, for more details. Sir, this is your news correspondent from the channel, The Elegant Equation. According to eyewitness reports, you accidentally found a computational glitch in one of your works. Can you please elaborate on this, sir? When you invited me to your class one time, on identities and units of measurement, you told us that you uncovered something wrong with the results of your computation. The answer seems normally correct, but mathematically it is wrong. But before you go into the details of how you resolved this glitch, can you please define in public what a conjecture is? If I remember it right, you said that a conjecture is a statement or expression that may be true and false at the same time, much like a paradox that is self-contradictory. In our conversation last time, after reviewing the outcome of your results, you told me that this 4,000 years mathematical glitch has never been resolved before until now. So today, can you please show to the public the right and correct way to approach this paradox on the units of measurement and your counter-argument debunking the rule that all numbers divided by zero are always undefined? You said before, sir, that units of measurement are like numbers. They also follow the same four basic operations of mathematics, namely, addition, subtraction, division, and multiplication. Thus, for example, using variables, if we add x with x, the result is equal to 2x. If we subtract x from x, the result is equal to 0. If we multiply x and x, the result is equal to x squared. And, if we divide x by x, the result is equal to 1. The last equation tells us that anything, whether it is a variable, number, unit, expression, or object, when divided by itself, is always equal to 1. That's why, combining variables with numbers, if we add 6 kilograms with 2 kilograms, the result is equal to 8 kilogram. If we subtract 6 degrees Celsius to 2 degrees Celsius, the result is equal to 4 degrees Celsius. If we multiply 6 meters and 2 meters, the result is equal to 12 meters squared. And, if we divide 6 seconds by 2 seconds, the result is normally equal to 3 seconds. But obviously the fourth statement is wrong. The result should be read as 3 seconds per seconds. But, again, this a double whammy. The correct answer should be 3 and unitless. Now with regard to units of measurement, if we add x kilogram with y kilogram, where x and y are numbers, and kilogram as the unit of measurement, the result will be equal to x plus y times kilogram. If we subtract x degrees Celsius with y degrees Celsius, where x and y are numbers, and c as the unit of measurement, the result is equal to x minus y times degrees Celsius. If we multiply x meter by y meter, where x and y are numbers, and m is the unit of measurement, the result will be equal to x times y times meter squared. However, if we divide x times second by y times second, the result is equal to x divided by y. But again, this is incorrect, as you said, since the result is again unitless. The fourth problem is again messed up. Aside from this unitless dilemma, you also told us in class that not all numbers divided by zero is undefined. You prove this claim by showing to us some mathematical principles and concrete examples that prove your proposition is valid. That's why, to your credit, you called these glitches in one umbrella as the Lawsin Conjecture. Well, sir, that's an interesting proposition. But to be fair, can you please allow me more to show to the public how you come up with your conjecture? In our last session, you told us that anything divided by itself is equal to 1. That's why 5 divided by 5 equals 1, x divided by x equals 1, kilogram divided by kilogram equals 1, and of course, 0 divided by 0 is also equal to 1. You also told us that any number multiplied by 0 is always equal to 0. Thus, if you multiplied 1 and 0, the answer is 0. And if you distribute 0 to the other side of the equation, where it becomes 0 divided by 0, the final result is 1. This is one of the pieces of evidence that proves 0 divided by 0 is equal to 1. Similarly, you took us also to another higher level to prove that 0 divided by 0 is equal to 1, by introducing us to how zeros adapt to the same four basic operations of mathematics. Can I show the public how you proved it? If we go back again to the rule that says x plus x is equal to 2 times x, then following the same logic, if we add 0 to 0, the result is 2 times 0. But since any number multiplied by 0 is always equal to 0, it follows that 0 plus 0 is equal to 0. The same rules of variables are also implemented when zeros are subtracted, multiplied, and divided. Thus, when we divide 0 by itself, the result is always 1. In your Q&A, you posted some proof of whether 6x divided by 2x is equal to 6 halves. You also posted another challenging question that involves quadratic problems. If you all are interested in the Q&A, please check out the channel, The Elegant Equation. To end this interview, let me summarize the key points about the Lawsin conjecture. First, when any number is divided by 0, the result is not actually undefined but obviously invalid. Second, when units of measurement are divided, the common unit is retained with a superscript degree that makes the equation more accurate and correct. And finally, rather having a unitless equation or misrepresented unit of measurement, it is much better to have a unit that is both visible and invisible at the same time. Thank you again, Mr. Lawsin, for your time and wisdom. Please stay tuned everybody. We gonna keep you updated on this marvelous discovery as new information becomes available. We are now returning to our normal programming. Take it away. Thank you for watching, and don't forget to subscribe, share, and like. This is the YouTube channel, The Elegant Equation. Have a great day, y'all.